My name is Peter Phaal, and today I'm going to be representing sFlow.org. I'm excited to be sharing some of the latest developments from the sFlow community, addressing the issue of monitoring high-speed AI/ML backend networks. I'd first like to thank the San Diego Supercomputer Center for making the Expanse cluster dashboard publicly available so anybody can look at this live dashboard. The Expanse cluster is a batch-oriented cluster for the research community. It processes tasks from researchers around the country and increasingly a large number of machine learning tasks. The dashboard summarizes the performance of the entire fabric. So this is a fabric level view, and each of this chart, I'm showing a month's worth of data. If you're looking at the live chart, you can zoom into any interesting feature or look at up to the second view of current data. So the first chart is just total traffic entering the fabric, summing traffic across all the ingress ports. The next one is looking at cluster services, so storage and orchestration. The next one is a histogram of link utilizations on the interswitch links. So this is giving you an idea of how load is being spread across the core as it goes across the fabric. And similarly, if you do a histogram of edge links, you get an idea of how spread the load is across the servers attached to the fabric. And this chart shows the mix of InfiniBand operations in the cluster. And the next one kind of drills into RDMA operations. And so we're now seeing how many I/O operations per second are running. And this one shows the average number of bytes transferred with each RDMA operation. And this one's kind of interesting. When you're running a machine learning task, you have compute and data exchange phases. And so this is telling you what the cycle time is for those operations. Congestion notification messages are interesting because it is an indication that there's throttling in the network. So you want to keep an eye on those. And then similarly with the credits in InfiniBand acknowledgements, it's giving you an idea of how the flow control is operating. Discards are critically important to manage, and this is summing discards across all the interfaces in the fabric. And I'm going to go into some detail as how you can troubleshoot those discards. And finally, you want to keep track of errors. They're usually due to problems with failing ports. So normally, if you're monitoring a cluster, you would use agents running on your compute nodes. The challenge with RDMA is the adapters bypass the Linux kernel and directly copy data into memory. And that means all of the Linux kernel doesn't see the traffic, and all the normal tools that you might be familiar with for monitoring traffic don't work. So the way you can address that is to offload the responsibility for seeing the traffic to the network. And using real-time streaming sFlow from the leaf and spine switches provides that data. It's a standard feature of pretty much every data center switch. It's implemented in hardware, works at any port speed, and it gives you two kinds of information that really help. It streams randomly sampled packet headers, which I'll be showing how you can decode and see the InfiniBand data. And then there are two really new things that I'm going to talk about is transit delay and queue depth for those samples and reporting dropped packets. So the first thing you need to do is enable sFlow. Generally, this is very easy. It requires a few commands, and you enable sFlow on all ports on all devices in the fabric. This example is using Sonic, but it's very similar for other network operating systems. So looking at the packet header, You can use T-Shark to look at the contents of the sampled packet headers, and we'll be stepping through the protocol layers. So the first one is Ethernet, and I'm highlighting fields that are generally interesting, the source and destination MAC addresses, and the priority. We get up to IP. You want to see the diffserv settings and ECN, and time to live, and source and destination addresses. You get up to the transport layer and you get an idea of what services are running. And then when you get into InfiniBand, that's where you get to see what the RDMA activity is. So what kind of operation is it? How much data is transferred? And a key thing with sFlow is that it's future-proof. So as Ultra Ethernet comes down the pike, there's nothing you need to do on the switches. It's just another decode in the analytics pipeline. So transit delay. This is a simple extension to sFlow that annotates the packet samples. So the ASIC will tell you the exact time it took for the packet to transit the ASIC, which queue it got put into, and how deep that queue was when that packet was added to it. And this is attached to every sample that's sent by the switch. And so with this information, you get to see where queues are building up in your network, what's driving those queues, and who's in the queue when you get microbursts. When the packet drops is a new kind of measurement. It gives you insight into every packet dropped in the fabric. It's not sampled. Instead, it's rate limited. So if you have a flood of drops, the rate limit prevents it from flooding the management system. But otherwise, you see every dropped packet. And what's contained in those drop events are the agent and port. So you know exactly where the packet was dropped. You know exactly why it was dropped. So in this case, it's an unknown destination network. And with the packet header, you get to know who's affected, what service is affected. And so this allows you to troubleshoot dropped events instantly, rather than trying to dig around and figure out why packets are dropped. And so the faster you can resolve these events, the quicker you fix them. So for more information, here's some links. And I would encourage everybody to turn on sFlow. You have it in your equipment. I'm sure you'll enjoy it, and engage with the community. You know, we're very interested in hearing your experiences, share best practices, talk to your vendors, and I hope you enjoy it.